Hi everybody. So today we're going to have something that's a lot of review, using some old skills that I'm sure you had wished I had forgotten about, but I haven't, and we can't because they're coming back. All right, we're going to be looking at polygons in the coordinate planes, in a coordinate plane, and we're going to have to use some necessary tools for classifying polygons by using distances, midpoints, and slopes. So we need to remember some of those important formulas like the distance formula, the midpoint formula, and the slope formula. So again, it's all coming back. This is out of our text section 6-7, and here's what it's all about. You're going to have problems that look like this. Can you tell whether triangle ABC is scalene, isosceles, or equilateral? So I'm going to let you think about that one, and we'll answer that question a little bit later. Another example of a problem you might have is, can you tell if parallelogram ABCD is a rhombus? What kind of tools would we need to find that one to determine whether that's true or not? And another example, we got quadrilateral kite, K-I-T-E, and if we connect all the midpoints, what would we classify? How would we classify the shape that's formed by connecting all those midpoints? So we're going to need to pull back some of our old information. We need to remember, in order to solve problems like this, certain things. For example, the distance formula. You're going to need this to determine if sides are congruent on a given polygon or a shape that we put on a grid. Okay? Or we can also use it on diagonals. Remember, some of our polygons are special quadrilaterals that we've talked about. We know that diagonals have to be congruent. For example, rectangles, right? So that would also be a tool where, or an instance where you may need to use the distance formula. So here's the distance formula again. And if you want to practice, from back in chapter 1, we had a problem that looked like this. So if you want to do a quick practice, go ahead, pause, and then answer will be coming shortly. Okay. So remember how to use the distance formula. You'll plug in the x coordinates, the difference between the two, square it, plug in the difference of the y coordinates, square it, add them together, take the square root, and you've got the distance. All right, so you will be needing that for this chapter. Next tool you might need, remember the midpoint formula, also back from chapter 1. All right, where we found that the x coordinate of the midpoint is at the mean value of the coordinates of the endpoint, the x coordinates of the endpoints, and that the y coordinate of the midpoint is at the mean value of the y coordinates of the endpoints. And you're going to need this to find midpoints of sides of triangles or quadrilaterals, or also you may need it to verify if diagonals bisect one another. All right, find if a midpoint matches the bisection point or an intersection point. All right, so if you need to remember how to use the midpoint formula, here is an example. Pause, answer coming now. Okay, plug in the x coordinates, add them up, divide by 2, you have the x coordinate of the midpoint. Plug in the y coordinates, add them together, divide by 2, you have the y coordinate of the midpoint. All right, so hope we remember that. Finally, we may need to use the slope formula. Difference in the y values divided by the difference in the x values, or rise over run, and we may need this to find whether opposite sides are parallel, for example, which might be an indicator of a parallelogram. Find out whether adjacent sides are perpendicular, rectangles and squares. Find out whether diagonals are perpendicular, that would make kites or rhombuses. So remember all those tools and all of the theorems that we've been working on, the properties of different kinds of quadrilaterals, and some of those are going to come in handy in determining the answers to the questions that are coming up. So if you need to practice on a slope formula, here's an example to practice with. Pause, answer coming now. All right, here we go. Now, so those first 3 problems, let's see how we're going to use them. Here's our first problem. Can you tell whether triangle ABC is scalene, isosceles, or equilateral? Of course, it's scalene. If it is scalene, all three sides will be different lengths. If it's isosceles, two sides will be the same length, and if it's equilateral, all three sides would be the same length. So, since I'm here in lengths, I'm thinking distance formula. Pause if you want to give it a try. Answer coming shortly. Here we go. So, I did 3 sets of calculations. All right. First, figured out the length of AB right there. Plug in those coordinates for the A point, 0, 1, and the B point, 4, 4. So we're going to put them in right there. Do our math. And find out that the distance of AB is 5. Next, I did the same thing for AC using the A values. Oops. A values, 0, 1. C values, 7, 0. Plug them into the distance formula. And we're going to find out that that value is the square root of 50. So, or somewhere just above 7, right? So far, no match. Finally, let's plug in the third set of values for line BC, or segment BC, right? With endpoints 4, 4 and 7, 0. Plug them in here. And we are going to find out when we finish the math that the length of BC is 5, which of course matches the length of AB. Therefore, this is congruent to this. We have an isosceles triangle. There's our answer. Okay, so example of how to do one set of problems we might have using the distance formula. Next example of a polygon in a coordinate plane. We said, is ABCD a rhombus? Okay, and we've got the points A to get at these coordinates B, C, and D. All right, so how are we going to go about figuring out whether we got a rhombus here? Okay, well, you know what? Think about it. Pause it if you need to. Come up with your ideas, and then I'll share with you mine. Ready? My first thought, okay, distance formula. I could do that 4 times like we did on the triangle problem. We did it 3 times. I could do it 4 times and find out if those sides are congruent. And if they are, obviously we will have a rhombus, right? But you know what? I'd rather not do the distance formula 4 times. So you know what? I'm going to remember theorem 616, which says that for a rhombus, the diagonals are going to have to be perpendicular, right? And that's going to be a whole lot easier to figure out than using the distance formula 4 times. So I'm going to take the 2 diagonals, and let's just mark them in here, AC, and find out the slope of that, right? Plug it into the slope formula. I find out that's got a rise of 5 and a run of 6, or a 5, 6 slope. BD, on the other hand, I find out the slope of that is -3/2. All right? Since these 2 slopes are not negative reciprocals of one another. That was ugly, but you get the point. Since those 2 slopes are not flipped and opposite signs, then the diagonals are not perpendicular. Therefore, ABCD is not a rhombus. All right? Make sense? Okay. Finally, our last problem says we got a kite, and we called it KITE. What is the most precise classification of the quadrilaterals formed by connecting the midpoints of the sides? Well, we better find the midpoints of the sides. All right, so pause. Here comes the answer. Okay. So, finding the midpoints of the sides, let's put a couple dots there. Midpoint of KI is at -2, 2. Midpoint of IT is at 4, 2. Midpoint of TE is at 4, -2. And the midpoint of KE, -2, -2. And as we connect the dots, we find that the form, or the shape, that is formed by connecting the 4 midpoints looks like that. And I'm hoping that you're able to see right now. Again, don't trust your picture, but we can check out certain things that we know, right? Opposite sides are parallel, right? We have a zero slope and a zero slope. All run, no rise. And over here, on the other hand, we have a undefined slope. All rise, no run. Same with that one. So, therefore, opposite sides are parallel. We know it's a parallelogram. Next thing we need to check. Okay. The zero slopes and the undefined slopes are, in fact, opposite reciprocals. It's like we have 1 over 0 for the undefined slope and 0 over anything, 0 over 1. And the negative sign doesn't matter where we put it. But anyway, since a zero slope and an undefined slope are, in fact, opposite reciprocals, the segments are perpendicular. We know we have a rectangle at the very least. And then we can check, of course, distances, find out if it is a square. But in this case, I can just count these things. This is 6. This is 4. All right, no square. So, therefore, the most precise classification we can put on this thing is that it is a rectangle. All right, so that's the kind of thing we're looking at. Remember those old tools, write a summary, and we will see you later.